In section 7.4, we're going to use the division properties of exponents. So what we have is in a quotient, the quotient property powers, the quotient of powers property says that what we're going to do is we're going to keep our base and we're going to subtract our exponents. Now, you can use that rule, but I'm going to show you the logic behind that, and you can also use the logic every time, and I'll tend to do that a lot because people understand it a lot better. This one's really kind of bad to start out with just because there's so many 10s. I have 12 of them, but I'll write them out. 4, 5, 6, 7, 8, 9, 10, 11, 12 10s. And on the bottom I have 4 10s. And what that means is that I could actually sit and cancel a 10 for a 10 on each one of these. What that does is it gives me 8 10s left on top. 1, 2, 3, 4, 5, 6, 7, 8 10s. That is the logic behind why we keep the base and subtract our exponents. So I'm going to go ahead and use that rule for the next part. If you want to write out 10 2s and 5 2s on the bottom, you will still see that you have 10 minus 5, which is a 5. You have 2 to the 5th left on top. Continuing on, we have some more of these problems where we keep our base and we subtract 10 minus 7, which gives us 3. I almost hate to do this because when we start getting into the other problems and we have maybe a 3 to the 7th over 3 to the 10th, my 3 to the 3rd isn't on the top anymore, and I want to show you this. So there's 7 3s, and here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 3s. And when I start canceling these, the leftover 3s are on the bottom, so I would have to have the answer of 1 over 3 to the 3rd. So I caution using the rule of subtraction because we have to remember that we could end up with a negative exponent. And that's what happens. 7 minus 10 gives me 3 to the negative 3rd, and that's why they end up on the bottom. So on this next one, I keep the base r. 9 minus 7 is a positive number, so I do know it's r to the 2nd power. The next problem, I keep the n. This is n to the 1st. 6 minus 1 is 5, and it is positive 5, so I know I have it on the top of the fraction. The last one, I keep my h, subtract a minus b, and that's exactly how I have to write it, a minus b, because they are not like terms. Now we're going to look at some expressions, and so when we simplify these, we're going to use our numbers first. I find that a lot of students find it easier, especially at first, to write them out. So if there are no negative exponents throughout the problem, what is sometimes easier for them to do is write down what this actually means. So it's 6a times b, and then I have negative 2a times b. So when I cancel, my b's cancel and my a's cancel, and I'm left with a b on top, and then you just treat your numbers as normal. 6 divided by negative 2 is negative 3. In the next problem, I have d on top and 7 d's on the bottom. When I cancel, I have nothing left on top, so that means I put a 1 there. And I have d to the 6 left on the bottom. Try to put a couple more problems on this video. So this first one says I have an a. I have 2 b's, b times b, and I have c times c times c. On the bottom I have a, and then c times c. The c's cancel, the a's cancel, and I'm left with b squared on the top and a c on the top.